All right. Just in case you were sleeping, I've got a 28-inch 4K monitor for the best question. All right. Wait your turn, buddy. Alrighty. Who wants to know about WebAssembly? It's like the worst named technology ever, right? I think Mozilla started off pretty well. They had Firefox and Thunderbird and great names, and now we're like WASM. It's terrible. And it's going to be everywhere. It's like so bad. It's too late. So my theory is that at Mozilla headquarters, wherever that is, Mount Everest, the Rockies, I don't know, they looked at the world and they said, geez, JavaScript gets so much love. I mean, people love JavaScript, even though they're these like evil forces trying to bring like other stuff into it. JavaScript's everywhere. But you know, it's only for people like us who use TypeScript and all these other things. How about we spread that love around? Let's get other languages in and, you know, get them to experience some of the JavaScript love. That's my secret theory of where WebAssembly comes from. All right, so just going backwards, has anybody got a good question now that you've been prepped? Hey? How do you get a beard like this? It's genetic, buddy. It's genetic. Genetics, that's another talk. It's a different conference. What am I? Not a question. Okay. That's exactly right. I know. So, you know, like everybody else today has been going up, stacks, frameworks, all sorts of stuff. We're not going there, we're going down, like Q Jamiroquai or something. Yeah. Why? I just told you, buddy, so that, you know, like, you know all that like mockery you experience, right? You know, and then the C++ guys are like, we're so much better. They're going to get the same thing soon. Because they're going to be targeting JavaScript, right? Well, they are already, but, you know, they'll have no choice soon. Okay. Yeah. Does it replace the V8 engine? Probably the best question so far, like the, you know, getting there. No. But it's a good question. I mean, these are the kind of things that come up, right? Sort of, not really, but it's, yeah, like, it's just sort of spreading the love, really. Like, more people are going to be able to play in the same space that we already play in. Why do you want standards? I mean, come on, you know. How many module loading systems? We're going to get more module loading systems now. And we're going to get more languages. Guys, it's going to get crazy. You know, if you think it's crazy now, just wait till this stuff hits production. This is going to get crazy. Yeah, last question for now. Yes. These are easy questions. All right. So, you know, most of my talk I made up on the fly, and I just cut and pasted stuff off the net, so sorry. So WebAssembly is a portable stack machine which is designed to be faster to parse than JavaScript, as well, comma, you can see the comma, it's very important, as well as faster to execute. They weren't too sure about that part, I think. But it's definitely faster to parse than JavaScript. Okay. The next definition I came across is probably more interesting. WebAssembly is a new low-level binary format for programs on the web that complements JavaScript's high-level interpreted nature. So it doesn't replace V8. All these engines, we've got the 4 big engines, WebKit, Firefox, Edge, Chrome, all of them are going to, and they've all got together now, and there's the PANCL guys and the WASM.js guys all got together and said, how can we add on the support for dealing with a low-level binary format for running programs in this thing called the browser? And I think the word browser needs to be reconsidered, right? Because we're all tending to write applications, really. The browser is almost becoming a kind of operating system. So, yeah, it's this binary format that's going to get interesting that we'll look at now. Okay, so like we said, we're going down. So WebAssembly is very, very simple. It's a simple little virtual machine that runs on top of the JavaScript runtime. And it quite literally supports 4 data types. These are them. Okay, integers and floating points. That's it. Okay, there ain't nothing else in there. You know how in a CPU you only have integers and floating points? Well, this is exactly the same. Where strings come from is a mystery. Classes, all that other stuff, don't worry about it, right? This is all that actually exists inside this machine. It just, as an interesting side thing is, I think at Google I/O this year, one of the guys talks through what the JavaScript runtime interpreter goes through when it encounters the plus sign. Have you seen that talk? It's really kind of crazy. Like, when it sees plus, it has to figure out like what are the types of the things on each side that you're doing. And this flow chart for like figuring out what to do when you see plus in a JavaScript source is absolutely crazy. And so one of the things they wanted to get away from was this kind of madness of interpreting JavaScript and just say, right, let's start at the base and then work our way up. Let's build a little virtual machine that literally runs next to this JavaScript interpreter that can deal with, machine level performance and a binary format. Okay. All right, so I'm going to take you very quickly through how it all works, and I'm not going to get into all kind of boring details with what are the tools that you can go and follow X number of different tutorials on how to install mscripton or Clang and get the LLVM backend, blah, blah, blah. But basically, the initial idea was that guys wanted to take C and C++ code and run it in the browser. We'll get into why you want to do such crazy things, but I think they were jealous. I really do. Okay. So let's say we've got a function called halver. It's terribly named. That just returns whatever value you pass and divided by 2. So you run that through your WebAssembly compiler toolkit, and it produces 2 kinds of output. One is the binary, and the binary is kind of hard for us as humans because we've lost that ability to read hex since, I think, 1963 or whenever it was when, we got different stuff going on. When they invented strings, I think that was the time. So you get this binary format, and then along with that, the specification defines a text format. And what's kind of cool is that text format is made out of Lisp. Seriously. It's a bunch of S expressions, and we'll get into like why it looks like this. But that function you just saw, that halver function, once it's compiled and you get the stuff out, literally generates this piece of WebAssembly in the human readable text format. Okay, so the important part here is this export and that func halver. Do you see that? So then we're doing something called an I32 division. So this is really low level, right? We're doing like integer divisions and that kind of stuff. Okay. Anybody got a good question at this point? The stakes are high, guys. This is ASM.js. So the ASM.js team and the NACL team and all of these guys got together and have been working for like a year to form this standard. Okay, so I think up and coming in Chrome 61, is an actual ASM.js to WASM converter. Yeah, but this is the way forward. So what you're looking at here is pretty recent. I think March now, Chrome 57 or whatever it was that got released, which had not Chrome, sorry, Firefox. Chrome's still a little bit behind. It's got a couple of things it still needs to do. Got released with support for the standard. So there is a standard in place now. There's a couple of holes we'll get into where they haven't got things going yet, but this is it. Yeah. Yes and no. So right now, our compile targets are JavaScript, right? Again, was just talking about ClojureScript, TypeScript, all these things. Doesn't really matter what you're doing. A Scala JS, you're compiling to JavaScript, some kind of ES level of the language, you know. You don't really care. You're writing in your cool, you got classes and whatever. You compile to JavaScript, right? You ship that JavaScript across the wire, hits the browser. The browser's got to parse that JavaScript and actually turn it into something that runs. Because there's a big job on the JavaScript side. So we're doing two things. One, we're saying, hey, can't you do more work when you compile and give me something that looks like this, which is much, much easier for the browser to consume. Okay. One of the things that's coming up, and I'll just preempt myself, is the streaming form of WebAssembly. So now if you can imagine, and I'll show you a demo now, which is about a 250 meg WebAssembly download. You're going to have to wait for that to download before you start, right? But if you look very carefully at this, and it's very careful choice on the part of the designers to make this a stack language, is that you can start loading this and running it as you start receiving it. You don't have to wait for the whole thing to come down the wire. Okay, so if your compiler is clever enough to figure out, okay, this is the entry point into the code, and these are the functions I'm going to need first, and then organizes the WASM file in load first order, you can get your application up and running before the download's finished. Okay. This is totally like mad, and this should be live in all browsers by the end of this year. Okay, it's live in Firefox now. Yeah. Yeah. There's that, what's that lovely word, inexorable, like, as soon a terabyte of data, who cares, Yes. It's exactly the same sandbox that your thing is, cross-site scripting, the whole lot is still there. This is now coming in just low level. So you've loaded all this other stuff, but now you've got this tiny module that you can pull in. I have no idea how much time I've got, so somebody just start yelling at me. Yeah, last one for now.
Is this not an integrated development sort of language?
No, this is assembly language, buddy.
Doesn't it perform like an intermediate language for other languages to compile to?
Yes, exactly. That's what it's for. I'll show you quickly. All right, so like the current state of affairs is you can't use this stuff directly. You still need to kind of bootstrap it into your JavaScript environment, because of course the main thing that's going to be running in your web page is JavaScript. So you'll always have, even if you're writing the majority of your stuff in C++ or whatever, you'll still have a kind of shim of JavaScript to get this going into the page. One of the limits at the moment is that the WASM stuff doesn't really have the ability to talk to the DOM. Okay. So here's just an example of getting it going. So we fetch test.wasm, and I get an array buffer out of that. So that loads 102 bytes. That whole C module, everything that got compiled there comes in as 102 bytes. That I can instantiate through this new WebAssembly object that's available in the browsers. Instantiating it gives me a module and an instance. It's kind of like a class and an object. The module can get reused. And there's a lot of work happening on the web workers. Are you guys up to speed on web workers? That's coming big time. And what you're going to be able to do is pass the module into web workers to get them to create their own instances to run. And then there's a whole thing with how they... So multi-threaded JavaScript, guys. It's happening. All right, and then you can just access the exports of that module, call it like a normal JavaScript function. It's pretty cool. So that could be doing some crazy ass C++, Gaussian blurs or whatever on a live video stream. You can call it. Load it into the browser memory space and just use it. Okay. So just some super important notes. It's not bytecode. Okay. We're not finishing the compilation. Each browser on each platform has to still do the final assembly step into actual machine instructions. So Firefox x86 or WebKit or whatever. But it's a binary format already of an abstract syntax tree, so it just makes it easy to add. This is one of the big things. This is why they're getting some kind of traction with it. They said, guys, we don't want to change the whole world, but if you could just kind of add this side door into the browsers, that would be great. The main thing is that this eliminates the parser bottleneck. You don't have to go looking through what to do for plus, right? This is just very low level, very straightforward. So does this make JavaScript faster? Well, for load time, yes, absolutely. I can totally see a time when everything will be shipped this way. Why not? I mean, I'm downloading 105 bytes, for goodness sake. It's much faster to load. And then I'll have a simple JavaScript shell to get all of this running. But once it's running, hey, I'm just sending, JavaScript's that kind of layer between the DOM and the stuff doing the work. It's one idea. So, I mean, JavaScript runs pretty damn fast, and there's some guys doing some very heavy animation demos, and in some cases, the WebAssembly stuff's super fast compared to the JavaScript. But on average, it's okay. But the load times, because of course you're downloading so much less, are incredibly much faster. All right, so what's this for? Let's go and see. Have you guys seen this demo? The Epic Zen Garden demo? So I'm just going to reload this. This is the 250 meg, I think it was made by Epic Games. So this is coming out of their game development engine, which is a C++ engine. It's kind of just being loaded down. There's a bit of JavaScript to bootstrap it in. Boom. And we're off. Yeah, you can see this on YouTube, right? It's like a video. So this is WebGL, and then, like I say, it's literally coming out of the game engine and just being cross-compiled to run in the browser. So what's getting very cool here is, of course, I can interact with this thing now and mess around. So huge potential for games here, right? Let's go look at some fish. Fish are cool. All right. But hang on a second. I just loaded 205 megs over my phone. How much did that cost me? Somebody? Actually, I didn't. One of the big features with WASM is you can cache it in the IndexedDB inside the browser. Okay. So because we've got this, it's exactly the same kind of bytecode. It's there. I've got it here. So there's a nasty button there that says clear the IndexedDB of all 205. I'm not going to press it. Then we won't be able to see fish, it's just fascinating. All right. Okay, so that's pretty cool. And that's pretty glitch-free, right? But that means guys will be able to retarget CAD programs, a lot of these heavy environments to the browser. You can't say to JavaScript anymore, right?
But most of that sort of stuff was done in real Engine 3, I think about
Yeah, yeah. But it's a standard now. Now you can make a game and ship it to all browsers. Like, think about it. Or to phones, you know? It's kind of mad. Like, yeah. Because we've got a standard now, everybody else in the world who's got a C++ application, I mean, somebody is going to port X Windows to run in the browser, right? And then they'll go, hey, you can have like this cool tool. Why not? I mean, somebody on Twitter said, why don't we run ASP, core in the browser? Sure, why not? See, it's going to get mad, right? It's going to get like, woo! Okay, before I go to more questions, let me show you the last piece. How much time have I got, Simon? 5 minutes. 5 minutes, guys. All right. This is the other one. All right, so what you're seeing here is just a text box, but that's not JavaScript, right? That's Lua. So in this example, I literally took the Lua source code, ran it through the compiler. It's the raw Lua source code for the Lua interpreter, and I have the Lua interpreter running in the browser. Okay, it's totally mental. And it's live, like, where is it? Hello world, can you kind of see that at the bottom there? Stupid browser. See, now I can't even get to, there we go. Okay, you're not too bad. So we just ran some Lua code in the browser and got some output back into the DOM, right? Whoa. It's kind of mad. I got some questions earlier. So would WebAssembly be suitable for situations where there are business requirements for protection of proprietary code? No. I mean, you can read it. It's just, like it used to be JavaScript, now it's WASM, right? There's no like encryption on this code. I mean, you'll get things like, what are those PHP code loader things with like keys? It'll get crazy. Somebody will try to do it. Dwayne asks, and this is the, the .NET Anywhere architecture. Somebody's already got it running in the browser. So it's like a subset of .NET that somebody's ported and got like literally running in the browser. So you kind of need to think about that a bit, like running web servers in your browser. But definitely for rich clients, I can see like windowing toolkits that have nothing to do with the DOM, that are purely writing to the canvas, WebGL, whatever, doing their own stuff starting to come along. Delphi, woohoo! Do I think WebAssembly will complement or replace current JS practices? It's just going to get crazy, man. We're going to need a lot more chemicals to cope with this. Yeah, like we were saying earlier, you'll get the call to like go and help somebody with their web application, and you'll have to preempt that with like, what is it? Like, I know, yeah, it runs in a browser, I know, but like, is it VB? Is it, oh, it's JavaScript, I can do that. So what's the debugging story look like? I guess that's part of your source language. I don't really know that there's an answer now for debugging that stuff in the browser. Because, I think there is some idea of having WASM source maps that's on the table right now, but that'll get kind of interesting, right? Well, I think the thing is you wouldn't debug it here. You'd debug it in your C++, Rust environment or whatever. You'd have unit tests there. You know, once it's shipped here, this is production. Yeah. Well, WebGL, buddy. So, I mean, the DOM's kind of there controlling that window, but you can ask for a gateway through into a canvas, and then that's pretty near real time. Yeah, so this is like the roadmap for Chrome at the moment, going all the way through to 2018. So, for example, things that are coming are like shared array byte buffers, so that you can, because you may have noticed in those types there are no arrays, right? So one of the things that's coming is how can we set up shared memory, especially between worker threads, so that if we've got like background things going on, we can get to them from the display layer or from other worker threads. Yeah. Cool. I think, yeah. How many more questions have I got time for? 3 more. Okay, go. No, this is an execution format. I mean, I guess once you booted up Common Lisp in the browser, you could go nuts, right? So right at the back. There is no garbage collection, buddy. Sorry? Yep. Yeah, you actually, if you want to pass memory through, in the WebAssembly object, you have to pre-declare it on that you want to get back, right? I mean, of course, if you're in the C or Rust world, it's up to that environment to do its own thing. But on the JavaScript side, if you want to like get an array filled, you have to pre-declare that, figure out what the target language does, like pass it through. I mean, it's low-level stuff, right? Yeah. Yes. Yeah, no. I think Azure's going to run inside Edge. I don't know. You can like download, get a version of Azure running in your browser. It's pretty weird, right? I mean, I got 2 more. Who hasn't gone yet? Right at the back. Yeah, it's happening. There's yeah. Like I said, it's shipped already. Yeah. I think we've got 1 more question. Yes. Yes. Sure. And then like freezing it and sending it somewhere else. Yes. Yeah, like it's gonna get very weird. like when this VM starts doing too much work, please start running it like where there are more resources. And when it's finished, bring it back so I can see what it did. Yeah. Like I don't know if you guys saw the demos of QNX in the like mid-90s. They were doing similar stuff, like, But this is becoming real now and accessible. At this point, you can learn Rust or whatever, do some kind of crazy stuff. It's starting to get very crazy. I signed up for the talk, buddy. Seriously, it's a way to learn something. Sign up for talks. Yeah. Okay, we're done. I don't have time. Hey, it's you next. Wait, more? How many more? 5 more? 2 more? 1? Are we finished? Okay. Thank you very much, guys. Whose question was the best? You didn't even ask a question, dude. That's ridiculous. Yeah, I do think you asked the best question, dude. Congratulations. What's the name? Cool. Come and get yourself a monitor, buddy.